Okay, ladies and gentlemen, welcome back to my channel. Now let's talk about solution properties. Solution properties, let's talk about first solutions. What are solutions? Solutions are mixtures of things or mixtures of what you call, number one, a substance that is dissolved in a liquid. You call it a solute. And then the liquid that is dissolving the solute is what you call the solvent. Now, when you mix these two together, you add them together, you get what you call a solution. Now, a solution is composed again of a solute and a solvent that is mixed together homogeneously. Okay, now that we have our solution properties in place, let's talk about how we express the concentration of our solutions. First, we have molarity. Molarity is expressed as the number of moles per 1 liter of solution. Take note, we are talking about the liters of solution. A solution that is 1 mole or 1 molar contains 1 mole of a solute per liter of the solution. So that means we use the following formula. Molarity is equal to grams of solute, which again would always be almost given. Your gram molecular weight, which you can compute for our chemical formula. And of course, your liters of solution, which will also be given. Okay, so that would be very simple. Now let's review how we compute for the gram molecular weight of a substance. For example, we have hydrochloric acid or HCl. When you have HCl, you get the atomic mass of each of the elements present. In this case, hydrogen is 1 and then chlorine is 35. In that case, our gram molecular weight is 36. Very good. And now we simply multiply it with the liters of solution and then use that resulting to divide the given. Next is molality. Molality is almost the same as your molarity, except it is spelled with the letter L instead of the letter R. It is also represented as a small letter m instead of the big letter M for molarity. It is expressed as the amount of solute per 1 kilogram of solvent, and it is computed using the following formula. Grams of solute, which is the same with your molarity, gram molecular weight, which is also the same as your molarity, but the only difference is that since this is, take note, 1 kilogram of solvent, we multiply the gram molecular weight with a kilogram of solvent instead of your liters of solution. Same formula, but this time we are given mass instead of volume. Okay, so that is simply the difference between molarity and molality. Now, something new and not very commonly encountered inside the laboratory is what you call normality. Normality is the number of equivalent weights per 1 liter of solution. Normality is equal to grams of solute over equivalent weight and the liters of solution. Now, very common, we know the grams of solute, we know the liters of solution. The only difference is that we do not know the equivalent weight. Now, to compute for the equivalent weight is actually very simple. Equivalent weight is equal to the molecular weight over valence. We know how to compute for the molecular weight, and now we have to compute for the valence. Now, the valence is very simple. It is simply the power of or the number of hydrogen atoms for acids and the number of hydroxyl ions for bases. Now, if you can recall in your basic chemistry, hydrogen at the beginning of a chemical formula will indicate that the chemical you're dealing with is an acid. And then hydroxyl ions at the end of a chemical formula will indicate that the chemical you are dealing with is a base. Very good. Now, we simply have to count the number of hydrogen ions and hydroxyl ions in the formula. So let's have an example. If you are given H2SO4, which is sulfuric acid, what do you think is the valence of this substance? Since this is an acid, all you have to do is look for the hydrogen ions. So since we have 2 hydrogen ions, the valence of this chemical formula is 2. Let's try another example. let's have sodium hydroxide. Now, since in sodium hydroxide, we only have one hydroxyl ion, it means that the valence of this substance is only 1. Now, I would like to put a disclaimer here, since this is not always the case for our valence, but for the purposes of our study, we're going to use this method. Okay, so that is how you compute for normality. Now let's talk about the relationship between molarity and normality. Now, if you have this kind of setup, I'm sure you remember the use of our triangle. Our triangle can be expressed like this. You have your molarity on the left side, normality on the top side, and then valence on the right side. Now, if one is missing, for instance, you have your normality missing, all you have to do is multiply your molarity times your valence. And in doing so, you can compute for your normality. Very easy, you don't have to compute again and again and again, because all you have to do is compute for one and then multiply it with the other or divide it with the other. Very easy. Okay, so do not forget the use of this very awesome triangle. Now let's talk about percent solutions. For percent solutions, we have 3 kinds. The first one being the weight over volume, which is very common. Very common because this is the most common example or most common computation that you will encounter in the laboratory. Now take note that we are going to use grams of a solute, which means that our solute in this case is a solid, over a volume of solution, or the total volume of our solution, times 100, because we are again dealing with percent solutions. And if you want to get the percent, you simply have to multiply it by 100. So that is your weight over the volume. Next is our volume over the volume. Now, volume over volume solutions are relatively simple as well and relatively common inside the laboratory. All you simply have to do is get the volume of the solute over or divided by the volume of a solution. Now, the only difference with our previous computation is that this volume of solute, or rather this computation, involves that the solute is actually a liquid rather than a solid like before. Same thing, all you have to do is multiply it by 100 and then you get your answer. Very easy and very simple. Now, less common than the other two is our weight over weight solutions. Now, our weight over weight percent solutions can be computed using the weight of a solute. So, our solute here is a solid, and in the weight of a solution, again, we can weigh liquids. We do not necessarily have to have a solid solution. We can weigh liquids and then multiply it by 100. Once multiplied, you get your answer. Very easy solutions. Very easy computations, very simple. Now let's try one problem and I will leave all the rest to you. So number 1, we have 77.4 grams of sodium chloride, which is dissolved in 250 ml of water. What is the molar concentration of the solution? Now, ladies and gentlemen, when we want to compute for the percentage of a solution, the first thing we have to do is, in the problem, is analyze of what is being asked. In this case, we are being asked about molar concentrations. Is it small letter m or big letter m? Very good. It is big letter M. Okay, and now the first step of our problem solving is that we identify the given. So we have 77.4 grams of sodium chloride and you have 250 milliliters of water. Very good. And then letter B, or the next step, is to compute for our additional information. So molecular weight of your sodium is 23. Your molecular weight of your chloride is 35. You simply add them. So the molecular weight of your sodium chloride is equal to, very good, 58. So now we can proceed with using the formula. So letter C is use the formula. Big letter M is equal to the grams of our solute, which is 77.4 grams, over your molecular weight or gram molecular weight times liters of solution. You have 58 grams times okay, so we do not use 250 milliliters of water because in our formula it demands liters of solution. And in that case, we simply have to convert 250 ml to liters of solution, which make it simply 0.250 ml. You input that in your scientific calculator and you have your answer. Okay, thank you very much for listening. That ends our tutorial for the percent solutions and the molar solutions. I hope you learned something new today. Please like and subscribe. And if you haven't yet, please share this video. It is very much appreciated. Goodbye.